Previously, we have established some fundamental theories about higher order linear differential equations like the superposition theorem, the existence and uniqueness of solutions, the basis of solution, that the fundamental set of solutions are linearly independent. And we were also able to identify if two sets of solutions are either linearly dependent or independent by getting the Wronskian of the function. These theories teach us of a number of systematic methods of finding the solution of higher order linear differential equations. What's up, guys? And welcome to Differential Equations. In this lesson, we're going to discuss a more straightforward way of finding the solution of homogeneous higher order linear differential equations. But before that, let us first remember that we are in the holy presence of God. In the name of the Father, the Son, the Holy Spirit. Amen. Scripture for today is from Joshua 1:9. It says, "Have I not commanded you? Be strong and courageous. Do not be frightened and do not be dismayed, for the Lord your God is with you wherever you go." We all face situations in life when we feel scared and alone. However, we can take courage from what this Bible verse says. We don't have to be scared or dismayed because the Lord is with us wherever we go. Many times, we can want to turn away from situations that seem scary or overwhelming. However, we can face those situations with confidence when we begin believing what this verse says. We begin to believe that we're not alone and that we've got God with us wherever we go. And with that, we can face any situations. Be encouraged that we've got God's help on our side. As Lasalians, may we respond and say, "I will continue, O my God, to do all my actions for the love of Thee." Saint John Baptist de La Salle, pray for us. Leave Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Now, before proceeding to higher order DEs, let us first begin to investigate homogeneous second-order linear differential equations with constant coefficients. So, let's take a look back and consider a first-order DE. If we consider here, as shown on the screen, a of x y prime plus b of x y equals 0, we know that the general solution is y equals c e raised to negative b of x over a of x multiplied by x. Do we still remember how we solve this? We have different techniques that we have learned from our previous lessons in order to solve a first-order linear differential equation. We have separable, right? We have, what else? Linear. We have homogeneous function. What else? We have exact. We have Bernoulli. This techniques here all can be used in solving a first-order linear differential equation, right? Now, looking at our given first-order DE, can be easily identified that this could be conveniently solved by using variable separable. And so, if we have a of x, y prime plus b of x, y equals 0, we can separate y double prime, no, and y, and or combine them together, because we know that y prime is also equivalent to dy over dx. So a of x is dy over dx plus b of x, y equals 0, correct? Now, if we transpose b to the other side, we're gonna get a of x dy over dx equals negative b of x, y. Now, if we separate and make all the y's on one side and make all the x's on the other side, we're going to get dy over y equals negative b of x over a of x multiplied by dx, right? All the y's on one side and all the x's on the other side. If we integrate both sides, we're going to get ln y equals negative b of x over a of x multiplied by x. And then, of course, plus c. We should never forget that. And then what we do next is we raise this all to e, no? And simplifying, finally, we're going to get an expression that is y, that is equivalent to y equals c, e raised to negative b of x over a of x multiplied by x. We know that this is the general solution, right, of first order linear differential equation. Now, aware of this, Leonhard Euler proposed solving an nth order homogeneous linear differential equation with constant coefficients by looking for a solution of the same form, e raised to mx, where m is the constant to be determined. So a common similarity he noticed is that the function, the exponential function here, could be a solution of higher order differential equations as well. And so if we focus on equations such as a of x y double prime plus b of x y prime plus c of x y equals 0, where of course a of x, b of x, and c of x in our case in this topic will be constants. In the succeeding or future lectures, we'll be dealing with a of x, b of x, and c of x as variables or polynomials. No? In this case, we'll be dealing this in this lesson, we'll be dealing with the coefficients a of x, b of x, and c of x as constants. Now, this can also be expressed as a y double prime plus b y prime plus c y equals 0, where of course a, b, and c are our constant coefficients. Now, sabi natin kanina, y equals e raised to mx is a form of a solution that we are trying to seek. So therefore, if we want to solve a second order linear differential equation, we can substitute this solution that we are seeking, y equals e raised to mx, into yung ating second order linear differential equation, a y double prime plus by prime plus cy equals 0. And if so, we will be needing, if this is a second order linear differential equation, we need to get the second derivative and the first derivative of our y. And we need to plug it into this functions here and check to see if it will satisfy the equation, equal to 0. Right? And so, in solving for y, seeking for a form of solution having y equals e raised to mx, we need to get the first derivative, which is equivalent to the derivative of an exponential function. As we may recall, the derivative of e to mx is m e to the mx, right? And so, differentiating, taking the first derivative, y prime will therefore be equal to m e raised to mx. And taking the second derivative, we're gonna get y double prime equals m squared e raised to mx. Ayun. Okay? Now, substituting it into here, to our second order linear differential equation, magkakaroon tayo ng a multiplied by what is our y double prime? Ito yun, no? M squared e raised to mx. So, m squared e raised to mx. Plus b, what is our y prime? Ito yun, m e raised to mx. And then plus c, what is our y? Ito yun, right? E raised to mx equals 0. We can actually factor out e raised to mx above, no? And we will be having e raised to mx quantity am squared plus bm plus c equals 0. Now, if we divide e raised to mx to both sides, no, we're gonna get a simple am squared plus bm plus c equals 0. Now, if we factor out e raised to mx nga, we will be having an expression that is equivalent to this expression here as the condition to be satisfied if y is equal to e raised to mx is to be the solution. In other words, we have to satisfy this whole equation. We need to find what m is if y equals e raised to mx will be our solution, is to be our solution. Okay? Now, getting that equation back again, am squared plus bm plus c equals 0. This algebraic equation is actually called as the characteristic equation, sometimes known as the auxiliary equation. Now, the characteristic equation is a simple quadratic equation which will be satisfied by two values. No? The characteristic roots we call m. Okay? So we need to find this m to satisfy if y equals e raised to mx is to be our solution. Right? And familiar na tayo dito, this is a quadratic equation from our algebra. This will define what we call our characteristic roots. Now, these characteristic roots are also called or termed as eigenvalues. Okay? Now, since we're talking about roots, if we will recall our algebra, there are actually three possibilities that we will encounter, three possible roots that we may encounter along the way. First is if we have real and distinct roots. So case 1, real and distinct roots. If the real and distinct roots of a characteristic equation are, let's call it m sub 1 and m sub 2, then the general solution is, if we will recall our previous lesson by the superposition principle, the general solution of a second order linear differential equation actually has the form y equals c sub 1 y sub 1 plus c sub 2 y sub 2. But since we are seeking a solution of the form y equals e raised to mx, no? And therefore, kung meron tayong makuhang roots na m sub 1 and m sub 2, we're going to get an expression of y equals c sub 1 e raised to m sub 1 x plus c2 e raised to m sub 2 x, where of course m sub 1 or e raised to m sub 1 x and e raised to m sub 2 x are y sub 1 and y sub 2 respectively. Okay? Now, what else? What else could be another possible combination of roots that we may encounter for a second order or a quadratic equation? Second order DE or a quadratic equation. Well, the next we may encounter is what we call real and repeated roots. Case 2, real and repeated roots. If the characteristic equation has repeated and equal roots, let's call m sub 1 and m sub 2 equals m, then the general solution, no, recalling again yung general form natin, y equals c sub 1 y sub 1 plus c sub 2 y sub 2, no, having our m sub 1 m sub 2 equals m, edi substituting again, seeking a solution of the form y equals e raised to mx, edi magkakaroon tayo ng y equals c sub 1 and then e raised to m sub 1x supposed to be, but since equal siya sa m sub 2 and m, let's denote it as mx, no? Plus c sub 2, again, e raised to mx. What can we notice here? We can actually factor out e raised to mx and get c sub 1 plus c sub 2 e raised to mx. Aba, teka lang. Since c sub 1 and c sub 2 are already constants, we can also express it as one capital C representing the two constants. Kasi constant din naman sila eh. Anyway, if you add two constants, it will just result to one constant, and then e raised to mx. Now, we have a problem here if this is our solution. Why? Because we are expecting two solutions for our second order DE. Ang problema, yung naandito lang na ibinibigay sa atin ay iisa. That's our problem. No? This cannot be because we are expecting two solutions that are linearly independent. Now, to illustrate further, let us consider a problem. Okay. For example, let us solve a DE with an equation of y double prime plus 4y prime plus 4y equals 0. Okay. So, we have here our equation y double prime plus 4y prime 4y prime plus 4y equals 0. How are we going to get the characteristic equation here? The characteristic equation here actually is if our equation is y double prime plus 4y prime plus 4y equals 0. The characteristic equation actually here is m squared plus 4m plus 4 equals 0. And so if we're going to factor this out, we're gonna get a root of m equals -2 and -2. Later, papakita natin some techniques how to find the characteristic roots. But for now, as an illustration, if you're going to solve for this, actually, you're going to have a root of -2 and -2. And this is a problem because our general solution has a form of c1y1 plus c2y2, right? And so as already illustrated earlier, it will have a form c1 e raised to, substituting -2 for m, -2x plus c sub 2 e raised to -2x. And so we're gonna get c sub 1 plus c sub 2 e raised to -2x, and then yun nga, y will be equal to, can be represented, yung ating c1 and c2 can be represented as one big capital C, because this will just be another constant, one constant, and there here lies in nga our problem, because we need two solutions for a second order linear differential equation. Okay, now how are we going to solve this? Because this cannot be, this cannot be. This cannot be because we are expecting, again, two solutions. Now, how are we going to solve this one? We can actually solve this one by employing one method. So, fortunately, long time ago, a mathematician named D'Alembert came up with a way to find the second linearly independent solution. So to find a general solution of an equation of our given DE problem, we need a second solution that is not a constant multiple of y1. In other words, that is linearly independent. The method we'll use is by the one developed by D'Alembert. And paano yung method ni D'Alembert? Now, recall that y sub 1 is a solution of the equation. This y sub 1 here is a solution of the equation, the second order linear differential equation as shown in the screen. So, if y sub 1 is a solution, then c sub 1, then c, represented by this capital C here, y sub 1 is a solution for any constant c that is. Now, the basic idea here is to generalize this observation by replacing this constant c, this constant c here, by replacing this constant c by a function, or a variable, let's call u, Yan. So, ang gagawin daw natin sa method ni D'Alembert, ang ginawa ni D'Alembert, he replaced this constant here with a function or a variable called u. Okay? So another function na itong u, no? Which is also a solution of the second order linear differential equation here. Now, to carry this out, we substitute y equals u y sub 1 back here to our linear differential equation, second order linear differential equation, and then use the result to find u. Okay? We will use the result to find u. In other words, again, to summarize or to point out again, no, yung c natin here is a constant and that u here is a variable or a function, no? So to illustrate further, no, let's go back dun sa ating problem. Yan. All right. So, going back, no? Let's try and solve this one. Okay. So, sabi natin, yung form ng solution natin, no, instead of c y sub 1, the form will be y equals u y sub 1. Alright? Now, if y equals u y sub 1, then substituting yung value natin for y sub 1 kanina na nakuha na natin, y is equal to u e raised to negative 2x, no? E raised to negative 2x. Ayan. And so, getting the first and second derivative, no, y prime, of this, so that we could substitute it back here sa ating given dE, by product rule, no? By product rule, naalala pa ba natin yung product rule? We can differentiate this factor here by product rule. And by product rule, differentiate daw yung first term, u prime v plus uv prime. No? By product rule, you get the sum of the alternating derivatives, no, ng factors. So, getting the derivative of u here, we're gonna get u and then e raised to negative 2x. And then plus, yung derivative naman itong second factor, e raised to negative 2. Magkakaroon tayo ng negative 2, then u, and then e raised to negative 2x. Correct? Yan. Now, taking the second derivative, we're gonna get, taking the derivative of this function or factor here, magkakaroon tayo ng u double prime, and then copy ko tong second term, e raised to negative 2x, and then plus, copyhin ko yung u prime, and then taking the derivative of this factor here, magkakaroon ako ng negative 2, u prime, e raised to negative 2x. Now, hindi pa tayo tapos dyan sapagkat kailangan din nating i-product rule itong second term, which is, take natin yung negative 2, and then u prime, kasi derivative ng u, then copy itong negative e raised to negative 2x, no? And then after that, let's take the second derivative, let's take the derivative of the second term. So magkakaroon tayo ng, copy natin si u, and then differentiate e raised to negative 2x, so magkakaroon tayo ng positive 4 u e raised to negative 2x. Okay? Yan. So we can simplify itong y double prime natin further, and we'll get u double prime e raised to negative 2x, and then I think I can combine this factor here because this is also equivalent to wala na pala tong u prime. Yeah. Yes, wala na pala tong u prime. Oops. Yan. So, u double prime e raised to negative 2x plus negative 2 u prime e to the 2x yan. We can combine these two together and we'll form negative for u prime e raised to negative 2x. Right? And then plus 4u e to the negative 2x. Alright. So, yan na yung y double prime natin. Ngayon, nakuha na natin yung ating y double prime. We can substitute this y, y prime, and y double prime back dun sa ating given DE here. Right? So, let's go ahead and substitute that. No? So, substituting, kasi in substituting, we'll be able to solve the DE. Kasi we'll be able to satisfy yung equation. Substituting to ano yun? Y double prime, given natin, plus 4y prime plus 4y equals 0. We're gonna get, yan, substitute nga natin. Ano yung y double prime natin? Our y double prime is eto, no? So, u double prime e raised to negative 2x minus 4 u prime e raised to negative 2x plus 4 u e raised to negative 2x. That's our y double prime. And then plus 4, ano yung y prime natin? This is our y prime, right? So 4 times u prime e raised to negative 2x minus 2u e raised to negative 2x. What else? Plus 4, and then ano yung y natin? Yeah, simply yung u multiplied by e raised to negative 2x. And then equals 0. Okay. Now what happens? Let's take a look, no? And investigate further. So, we can simplify, no, this equation by taking a look and noticing that actually 4u prime negative 2x cancels out here kasi pag dinistribute mo itong 4, magiging 4u prime e raised to negative 2x plus 4u prime e raised to negative 2x. And then we will also notice na if we distribute this 4 here, magkakaroon tayo ng negative 8. And then u e raised to negative 2x and then 4 u e raised to negative 2x. These two could be added, no? These two, it will become 8 u e raised to negative 2x. And meron ka ding negative 8 e raised to negative 2x dito. U e raised to negative 2x. So, ano mangyari sa kanila? Yes, they will cancel out. Anong matitira sa atin? Yes, you got it right. Ang matitira sa atin is u prime e raised to negative 2x equals 0. Now, this e raised to negative 2x here can be cancelled, could be divided to the whole equation, no? And so, we'll be able to simplify this as u prime equals 0. Now, yung u prime, yung need natin i-determine, ano? What will be our u prime? To determine u prime, or u double prime, or to determine a simple expression of u, okay? Kasi yun yung kailangan nating substitute back kanina para mag-get natin yung, or ma-distinguish natin yung difference ng two solutions. To determine yung ating u, no? We need to integrate. Because u double prime, since u double prime is also equivalent to d squared u over dx squared, right? And we need to integrate twice to be able to get an expression. Okay? And so integrating, since this is equivalent to 0, no? If we integrate both sides, or rather separating the variables, no, equal to 0 muna. Okay, sige, lagay ko na lang dito. So magkakaroon tayo ng d squared u equals 0 times dx squared, right? And if you integrate both sides, we know that anything multiplied by 0 will be 0. So this will simply become just du over dx equals 0. 0 plus, let's call it c sub 1. Okay? Kasi nag-integrate tayo, kailangan natin ng integrating factor. Now, integrating this again, no? Ating arbitrary constant c1 was produced because of our integration. Integrating this again, or rather, separating yung du and dx natin, magkakaroon tayo ng du equals c1 dx. Right? c1 dx. Then what happens? If we integrate this again, no, both sides, we're going to get and arrive at a value of u, which is u equals c1x plus c2. Yan. And this, ladies and gentlemen, will be the form of our c, or u rather, no, that we will be substituting back doon sa ating kaninang form of solution, which is y equals uy1. Okay? And so, if we substitute it back, no? Substituting it back, to our y, magkakaroon tayo ngayon ng y, sabi natin kasi kanina, c multiplied by e raised to mx, right? And then what we did is we substituted u there by the Allenbert's method, u e raised to mx, no? Then therefore magkakaroon tayo ng solution na y equals c sub 1 x plus c sub 2 and then e raised to mx. In this case, yung m natin is negative 2, no? So e raised to negative 2x. So in general, may form siya na makukuha. A general solution, kapag ka repeated yung term, seems to have a form of y equals c sub 1 x plus c sub 2 e raised to mx. Ayan. So, ganito pala yung form pag ginamit natin yung D'Alembert's method pagka kinukuha natin yung eigenvalues or roots. Ito yung form ng solution, ano, kapag ka yung eigenvalues or yung roots ay repeated, real and repeated. So, please take note of this, no? Y equals c sub 1, x plus c sub 2. That quantity is multiplied by e raised to mx. And so, for case 2, real and repeated, having the same or equal roots, m sub 1 and m sub 2, if the general solution has a form of y equals c sub 1, y sub 1 plus c sub 2, y sub 2, na kanina nga, na-prove natin na magre-result into a single solution, we will be able to identify, no, the second solution by simply, yan, ito yung form. Y equals c sub 1 plus c sub 2x. Now, some of you may recognize na, teka sir, di ba yung x nandito sa c sub 1? Yes, same lang sila. By superposition principle, it can be interchanged. But for the sake of a more organized manner, which we will see later, pag nag-higher order na tayo, nilagay ko siya sa c sub 2x. Pero same lang sila. Either way, no? Either way. So, but by matter of preference, I prefer c sub 2 to have that factor of x. Kung mapapansin natin, the differentiating factor between the real and distinct and real and repeated is that meron siyang multiplied na x in one constant. At yun yung pinrove natin from our previous illustration. Okay? So I hope you're getting this. So first case, real and distinct. Second case, we have real and repeated. For the third one, meron tayong complex roots. Yan. So, if the characteristic equation has complex or imaginary roots, say for example, m equals alpha plus or minus j beta, then the general solution is this form. Y equals c sub 1 cosine beta x plus c sub 2 sine beta x. Quantity e raised to alpha x. Saan po nanggaling yan? Well, actually, kung babalikan natin uli, galing dun sa general solution natin that has a form of c sub 1, y sub 1 plus c sub 2, y sub 2, right? And we know that this root here could, this complex roots here, kasi second order nga, 2 roots or eigenvalues ito. So, ano yung first eigenvalue? Alpha plus j beta. The second is alpha minus j beta, right? Now, if that's the case, and we plug this in here, magkakaroon tayo ng c sub 1, and then e raised to alpha, no? Raised to alpha plus j beta, and then multiplied by x, and then plus c sub 2. Ano yung second natin? Yes. E raised to the root being m sub 2 alpha, no, minus j beta, and then multiplied by x. Alright? Now, paano siya naging ganito? Paano siya naging cosine and sine? We may recall that from our algebra, we were taught of Euler's formula, no? Now, bakit tayo nag-arrive dito sa cosine and sine? The reason why exponential roots has to be converted to sine cosine function is this: because initial value problems has only real coefficients, okay, not imaginary. And it is often desirable to express the solution of such a problem in terms of real valued functions. So kung meron tayong imaginary roots or imaginary functions, tapos ang nire-require naman ng ating problem ay real coefficients, edi we need to convert yung ating imaginary, yung ating complex roots or yung complex expression ng roots natin into something that is real. And this Euler's formula here makes that possible because according to Euler, no, the relationship between the imaginary, the complex exponential e raised to j theta has an equivalent function or expression of c sub 1, or rather walang c sub 1, cosine theta plus j sine theta. Consequently, e raised to negative j theta is equivalent to cosine theta minus j sine theta. Okay? Now, also, we may recall some functions or properties that cosine theta is also equivalent to e raised to j theta, no, plus e raised to negative j theta over 2. And sine theta equals e raised to j theta plus, or minus rather, e raised to j theta minus e raised to j theta, negative j theta, all over 2. Now, anong meron dito sa dalawang properties na ito? Because from this, dito natin makukuha yung ating combination of solution that's why we arrived with this function here of y equals cosine beta x plus c2 sine beta x e raised to alpha x. Because if we're going to get y1 actually will be equal to cosine beta x plus sine beta x e raised to alpha x, tama? No? And y sub 2 being the negative part, we're gonna get cosine beta x minus j sine beta x, and then e raised to alpha x, right? By properties of exponents, no? Now, anong meron dito sa y1 and y2? Since they can be linearly combined, and linear combination of solutions are also solutions by superposition principle. And therefore, if we combine the two, y sub 1 plus y sub 2, no? Y sub 1 plus y sub 2 will just be equivalent to e raised to alpha x, no? Cosine beta x, whereas y sub 2, okay, actually y sub 1 plus y sub 2 over 2, and y sub 1 minus y sub 2 over 2 is equivalent to e raised to alpha, no, x sine beta x. And so, pag inad natin yung positive and yung negative, mag-a-arrive lang tayo sa addition nitong dalawang ito. That is why, no, by linear combination, mapa-positive or mapa-negative. Actually, complex conjugate siya. So, pair siya lagi. Plus-minus siya lagi. Kaya naman, kung meron kang plus-minus as denoted here, your beta will always be positive here. Yan. Ito. Okay? So, doon ang galing itong formulang ito na y equals c sub 1 cosine beta x plus c sub 2 sine beta x and then multiplied by e raised to alpha x because of these two functions here and from the other derived identities na pinakita ko po sa inyo kanina. Okay? So, I won't much elaborate on that. The technique or the idea is simply just if we're being asked to find the general solution, tas nakita natin na yung roots or yung eigenvalues natin has complex conjugates, meaning plus or minus alpha plus or minus j beta, then the form of the solution will be this one. Okay? So yun. I hope you're following. Now to summarize, the solutions that are possible for a second order linear differential equation, summarizing the three cases of case 1, real and distinct. Ito yung ating general solution here. Pagka case 2, real and repeated, meaning yung roots mo are equal, m sub 1, m sub 2 equals to m, no? Having this general solution here. And finally, case 3, complex roots, where m is equal to the complex conjugate, alpha plus j beta and alpha minus j beta, will give us an expression of the solution y equals c sub 1 cosine beta x plus c sub 2 sine beta x. Alpha, or that quantity is multiplied by e raised to alpha x. So that three cases there, no, that must be considered. Now, here's a proposed strategy, no, in solving a second order linear differential equation. When you encounter a problem that is asking for the solution, tapos second order siya, you may want to take note of this strategy. Una, find the characteristic equation. Okay? Find the CE. At paano natin makukuha yung characteristic equation? Based dun sa ating derivation kanina, since we're seeking a solution of the form e raised to mx, pag meron tayong second order linear differential equation, a y double prime plus b y prime plus c y equals 0, makakaasa tayo na ang ating characteristic equation will be am squared plus bm plus c equals 0. Sa makatuwid, as an example, no? For example, kung meron tayong y double prime minus 4y minus 12 equals minus 4y prime minus 12y equals 0, makakaasa tayo na ang ating characteristic equation ay merong form na ganito, m squared minus 4m minus 12 equals 0. Ayun. So, ganun mag-convert ng equation, no? Ng DE papuntang characteristic equation. So, unang-una sa lahat, hanapin mo muna yung characteristic equation. Pangalawa, you have to find the eigenvalues or the characteristic roots. And that is our m. At pag meron tayong characteristic roots na hinahanap, what are we going to employ? We're going to employ the usage of our quadratic formula. Naalala pa ba yung quadratic formula? The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Tama po ba? Now, that's one way of solving yung ating m, yung roots natin. But there is another way. This is one way, and the other way that I'm going to teach you later using our using an example is through calculator. Yon. I'm going to teach you a technique in finding the roots kung hindi nyo pa alam. Pero I'm pretty sure some of you already know this already. And finally, after getting the roots or the eigenvalues, based on the nature of the roots, we will be forming the general solution base doon sa ang case magfo-fall yung ating yung nature ng roots natin. So for example, kung yan ay real and distinct, then that's case 1. If that is real and repeated, then that's case 2. If it is complex, then it will fall on case 3. And we know that there are corresponding general solutions for that. Okay? Ayan. These concepts that we have learned are better understood or appreciated by means of some sample problems. And so the following problems will hopefully enlighten us of the concepts we have learned. So prepare your pens and paper, and so let's solve this together. So example 1. Solve the DE given as 2 d squared y over dx squared plus 5 dy over dx minus 3y equals 0 when we have here a given condition y of 0 equals 4 and when y prime of 0 equals 9. Okay, so let's solve this. So first we need to form our characteristic equation. Okay, based on our given differential equation, our characteristic equation is 2m squared plus 5m minus 3 equals 0. Okay, and as I've mentioned earlier, we have two ways in figuring out or solving for m, and that is first by looking at or using the quadratic formula to solve for m, or we can utilize our calculators to solve for our roots. So let's go ahead and bring out our calculators. So kung meron tayong quadratic equation here, 2m squared plus 5m minus 3, we can actually get the roots, because that's the next step that we need to go or to figure out. We have to find the eigenvalues or the roots, in this case m. So using our calculator, kung meron kayong Casio 9-in-1 ES or Casio 570 ES that looks like our calcu here, just go to mode, mode, and then equation, that's number 5. Go to 5, and then go to 3, because our equation here is a quadratic equation. So that's number 3. ax squared plus bx plus c equals 0. Now, take note of the format ng equation. You will notice na it's an implicitly expressed equation dahil it is equal to 0, meaning all of the terms of the equation are on one side of the equal sign. So a x squared plus bx plus c, the constant, is on one side, so equal to 0. So looking back at our equation, satisfied naman yun because we have here 2m squared plus 5m minus 3 equals 0. So therefore, ang gagawin lang natin dito, we'll just have to go to 3 and then input yung coefficients. So 2, 5, and then negative 3. And then equals, boom. Meron ka ng values for your m. And it is m, equals x sub 1 daw is 1/2. So that's 0.5. and m is equal to negative 3. Yan. Alright? So, characteristic equation, get the eigenvalues. And next step is to form the general solution. Okay? How do we form the general solution? Based on the nature of the roots, 0.5 or 1/2, and negative 3, what can we say about the roots? It falls under case 1. That is real and distinct. Okay? So, since it is case 1, the general solution for case 1 is y equals c1 e raised to m sub 1 x plus c2 e raised to m sub 2 x. Where m sub 1 is yung 0.5 natin and m sub 2 is negative 3. So, let's go ahead and substitute that value. So, meron tayong y equals c sub 1 e raised to 0.5, then x, and then plus c sub 2 e raised to negative 3 x. Ayan. So we now have our general solution, but we're not yet through because what's being asked actually is what? The particular solution. It is an initial value problem, no, that we need to solve. So applying our conditions, solution. Applying our conditions, and that is at y of 0 equals to 4. At y of 0 equals to 4, no? Meaning, we have to apply yung condition that y, this y is 4, no? And that x here is equal to 0. Saan natin i-apply yan? We're going to apply it sa ating y, which is our general solution. Here, no? This one. So in other words, let me just write it. C1 e raised to 0.5x plus C2 e raised to negative 2x, or rather 3x. No? And then, substituting or evaluating, given the conditions, we'll arrive at 4 equals c sub 1 e raised to 0.5 times 0, no? Dahil y of 0 siya, plus c sub 2 e raised to negative 3, again multiplied by 0. And we know that e raised to 0 is 1. E raised to 0 is 1. So magkakaroon tayo ng 4 equals c sub 1 plus c sub 2. So meron tayong two unknowns here. Let's call this first equation A. Okay? Equation A. Now, let's apply our second condition. And that is at y prime of 0 equals 9. Okay? Now, where are we going to apply this condition, y prime of 0 equals to 9? We know that, again, similar to our previous condition, this 9 here is y, and that x here, that 0 here is x. Now, where are we going to apply this condition? I-apply lang natin siya for the first derivative of y, kasi y prime eh. So, hindi pa naka-first derivative yung y. We need to differentiate this y here so that we could apply the condition. And so, y prime, getting the derivative of this y here, we're gonna get 0.5, no? C sub 1 e raised to 0.5x plus C sub 2, but yung e raised to negative 3x, derivative is negative 3, right? And then C2 e raised to negative 3x. And so therefore, evaluating and or applying the condition, meron tayong 9, right? Equals 0.5 C1. Saan galing yung 0.5? It came from this, the derivative of EU. Alala pa? EU, DU? Yes. So C sub 1, e raised to 0.5 and then multiplied by 0. And then plus, and or minus pala, minus 3 c2 e raised to negative 3 and of course multiplied by 0. What can we notice here about the solution? Here, e raised to 0 will become 1. And then here as well, e raised to 0 will become 1. Therefore, we have an equation of 9 equals 0.5 c1 minus 3 c2. Okay? We have again two unknowns here. Let's call this equation B. So we have two equations and we have two unknowns. We can employ these are two linear equations, no? So by system of linear equations, we have some ways. We have different ways, no, various ways of solving these two equations and two unknowns here. So let's just suppose lang, no, yung equation A and equation B. Equation A is 4 equals c sub 1 plus c sub 2, and equation B is 0.5, or rather 9 equals 0.5 c sub 1 plus or minus 3 c sub 2. We can employ techniques, no, in solving c sub 1 and c sub 2. Pwede tayong mag-substitution. Pwede tayong mag-elimination. But my preferred method is to use our calculator. Yes, because we could. So, paano sa calculator? Ganun ulit. Punta tayo sa mode, no? Let's go to our mode. Mode. And then, punta tayo ulit sa equation. That's 5. And then, you will notice na may 4 options tayo rito. Obviously, yung 1 and 2 yun yung linear. And then sa 1, we have two unknowns here, x and y. So, again, notice the form. A sub n multiplied by x plus b sub n y equals c sub n. So, ito naman, explicit yung expression, ano? Kasi yung constant c sub n, yung nasa right-hand side of the equation. Whereas the unknowns are all isolated and are moved to one side of the equation. In other words, we need to have our equations form like this, no? For us to be able not to mistake yung ating signs. So, looking back dito sa ating given equation, ano, so far, naandun naman siya sa form na yun. Itong constant na nasa left-hand side, and then c1 plus c2, and then itong 9, nandun din, nakaseparate. Then you have 0.5 c1 minus 3 c2. So, let's go ahead and proceed dito sa ating calculator of choosing 1. So, papansin natin, meron tayong two matrices here, or two rows. No? We have A, B, C, no? 3 columns, 2 rows. One column, one row for equation A and one row for equation B. Actually, interchangeable naman sila. Ang important here is yung coefficients in their side. So, let's choose equation A for row 1. So, kunin natin yung coefficients. This is C1 and C2. So, C1, C2, 4. So, that's 1, 1, 4. Right? 1 equals, and then 4. Yan. Next, we have 0.5, negative 3, and then 9. 0.5, negative 3, and then 9. Ayan. Boom. Press equals lang, and then if x is equal to c sub 1 and b is equal to c sub 2, then our value for c sub 1 is 6, no? And for c sub 2 is, check natin sa calcu, yun, negative 2. Yan, we have negative 2. Now that we have our constant c sub 1 and c sub 2, we can now proceed and complete, no, yung ating solution. Since we're being asked an initial value problem to be solved, edi kailangan natin siyang substitute lang yung value ng c sub 1 and c sub 1 dun sa general solution natin. So if our general solution, no? Goes like this. Y equals c sub 1 e raised to negative, ano yung ating roots or eigenvalues? 0.5, right? And then plus c sub 2 e raised to negative 3x, right? Then our particular solution, applying yung ating value for C1 and C2, will be 6 and then e raised to 0.5x minus 2 and then e raised to negative 3x. Ayun. And that's it, ladies and gentlemen. This is the answer that we're looking for. The solution to our initial value problem. All right. So let's move to another example. Yeah. So how about this? We're being asked to solve for, again, another DE. So again, from our strategy, given this DE here, ang una nating hanapin ay yung ating characteristic equation, right? Our characteristic equation. The characteristic equation here is, or can be converted by inspection, 9 to be 9m squared minus 24 plus 16 minus 24m rather plus 16 equals 0. All right? Okay. Now, next, what's our next stage or next step? We need to look for the eigenvalues or the characteristic roots, which is m, right? So how do we look for, again, the eigenvalues? Simple, no? Calcu and chill. Yan, yung ating natutunan. So, punta lang tayo sa calcu natin. And then, again, mode. Very easy. Mode, and then 5, and then yung quadratic equation natin, that's 3. And then, let's input in our coefficients. 9 minus 24, and then 16. And then equals, boom. We have m equals 4/3. And 4/3 and, check natin. Equals pa ulit. Wala nang lumabas sa calcu, no? Sa pa ulit. Isa lang, x equals 4/3. Pagka po ganyan ang lumabas sa calcu nyo, ang ibig sabihin po niyan, repeating yung roots. Okay? Kasi tayo ay nagsosolve ng quadratic equation, makakaasa tayo dapat na mayroong dalawang roots ang ating equation. Pero pag po lumabas sa calculator nyo na x is equal to 4/3 lang, walang x sub 1 or x sub 2, ang ibig sabihin po nun, yung x sub 1 is equal to x sub 2 is equal to x, which is 4/3. In other words, the roots are 4/3 and 4/3. Parehas. So very obvious na here that this is a case, this will fall under the case of case 2, which is real and repeated. Case 2, no? Real and repeated. And pag real and repeated, ano pong maasahan natin sa general solution natin? Y equals, yes, yung na-derive natin, c sub 1 plus c sub 2 x, no? Then e raised to mx, where of course m is simply 4/3. Sa makatuwid, the general solution is what? It will be y equals c sub 1 plus c sub 2 x, and then e raised to 4/3. 4/3 x. Yan. So this is our general solution. But then again, we are given a condition. This is an initial value problem. And so if we have an initial value problem, we need to satisfy yung C1 and C2 by employing yung given condition. Sabi dyan, when t is equal to 0, y daw is equal to y prime is equal to 3. And so, solution, applying yung ating given condition, we have at, no, itong expression na to, y equals y prime is equal to 3. Ibig sabihin yan, y daw is equal to 3. Yan. When x or t here, in this case pala, hindi pala x, no? So, yung ating variable is t. T. And lastly, t. Yan. Okay? When y of 0 equals 3. In other words, ito yung ating value for y at ito yung value natin for t. And so, applying yung condition sa ating y, which is this one, we're gonna get y, lagay lang natin, anong copy natin, c1 plus c2t, and then e raised to 4/3 t. Applying this will give us, anong value natin for y when t is equal to 0? Yes, 3. Ito. And then equals c1 plus c2, and then multiplied by 0. And then e raised to 4/3 again multiplied by 0. Yan. And so evaluating our DE, we know that e raised to 0 is 1. And we know that anything multiplied by 0 is 0. So further simplifying, we'll be getting 4 equals, 3 pala. 3 equals c sub 1, and then this is multiplied by 1. So, c sub 1 equals 3. Ayan. So, tapos na tayo sa paghanap ng c sub 1. How about yung ating second condition? When y prime of 0 daw is equal to 3 again. So, we need to take the first derivative of y, and that is, if this is c1 plus c2t, then multiplied to e raised to 4/3 t, then we can use the product rule. Tama? So, by product rule, nalala pa ba? That's u prime v plus uv prime. So, if this is our u and this is our v, excuse me, then taking the first derivative, we'll be getting first derivative ng itong nasa loob. Derivative ng c1, where c1 and c2 are constants, no? Will be 0 plus, well, c2, right? And then, copy yung 4/3, e raised to 4/3 t. And then plus, kasi product rule siya. Second derivative naman, yung derivative naman ng second term. So, copyhin natin si c1 plus c2 t. And then, yung differentiate natin is c e raised to 4/3 t. So, this will become 4/3 e raised to 4/3 t. Yan. Oops. Okay? So, simplifying, meron tayong yan. Simplifying, meron tayong y daw is equal to 3. So, 3, this will be, and then this will become c2, and then e raised to 4/3, positive 4/3 yun, no? Yes. 4/3 multiplied by 0. Plus, yan, eto, c sub 1 plus c sub 2, and then t is 0, right? And then multiplied by 4/3, e raised to 4/3, and then again multiplied by 0. Yan. Okay? So, evaluating, magkakaroon tayo ng 3 equals 3 equals c sub 2. We know that e raised to 0 is again equal to 1. We know that any number multiplied by 0 is 0. E raised to 0 again is 1. So simplifying, meron tayong c2 plus, ayun, 4/3 times c1. 4/3 c1. Okay? And further simplifying, since we know already c1, our c1 is actually this one, right? And so we'll have an expression of 3 equals c2 plus 4/3 and then multiplied siya by 3. No? Yan. We know 3 cancels out. This becomes 4. And when transposed, 3 minus 4, c2 is equal to -1. Yan. So c2 equals -1. Ayan. So we now have our two unknowns, c1 and c2. We can now proceed and 3 and -1. We can now proceed and form the solution of our initial value problem. So kung yung general solution or yung homogeneous solution has a form of c1 e raised to, ano yung value natin for m, 4/3. So this will become c sub 1 plus c sub 2 t, right? And then e raised to 4/3 t. This is our general solution. And then when applied by a condition sa ating initial value problem, magkakaroon tayo ngayon, since we figure out already c sub 1 and c sub 2, we'll have c sub 1 as 3, no? 3, and then -1, that's minus t. Then e raised to 4/3 t. Ayun. And that, ladies and gentlemen, is our solution for our initial value problem. We have now defined c2 and c1, which is -1 and 3 respectively. So 3 minus t multiplied by e raised to 4/3 t. Okay? So I hope you're getting this. Rewind it kung medyo feeling nyo mabilis or if you need to catch up. Okay. Now moving on to the next problem. The next problem goes like this. No? So we have, again, a differential equation, no? And you know what to do already, right? Una, ang kailangan natin kunin is the characteristic equation. And the characteristic equation is kind of easy because by inspection, we can already deduce that the characteristic equation is m squared plus 6m plus 13 equals 0, right? And from this characteristic equation, we need to figure out, no, what is our eigenvalues or our roots. That is m. Okay? How do we figure out our eigenvalues? Yes, by means of our calculator again. So let's bring out our calculator and put it in mode 5 and then 3. Yes, mode 5, 3. So from mode 5, 3, we can get our eigenvalues m. So let's plug in our values. No, we have 1, we have 6, and we have 13. equals? Okay. So, meron tayong roots na -3 plus j2 and what else? -3 minus j2. Okay. By the way, same lang yung notation ng j tsaka ng I. J is just another notation, no? Because for electronics, electrical, and computer engineering, I is usually used for current. And so sometimes it's confusing when we see I together with another value. That is why in a standard that was set by early engineers long before, they have set that instead of I for complex numbers, why don't we make it J? And then dun siya sa ilalagay sa beginning instead of after the number. Okay? So, J siya, not because the first letter of my name, Joshua, is J, but because it has been a long standard already, a de facto standard for most electrical computer and electronics engineers. Most engineering disciplines that deal with circuit analysis and or current. Okay? Kasi current nga, our symbol for that is I. I equals. So just imagine, I equals 2I. So baka i-cancel nyo yung I. So wala na matitira. It would be very confusing. Okay? So please bear with me. I'm going to use the notation J instead of I, as I am an electronics engineer. So, m is equal to -3 plus j2 and -3 minus j2. So, again, quadratic equation, meron tayong 2 roots. And since meron tayong complex roots, at hindi lang complex but complex conjugate, no? In other words, this can also be expressed as -3 and then plus or minus j2, then definitely this the nature of the roots falls under ano kayang case? Obviously, case 3, no? Complex roots, which has a general solution of y equals, yes, c sub 1 cosine beta x plus c sub 2 sine beta x and multiplied with quantity e, the exponential function raised to alpha x. Okay? And so substituting, we know that this is our alpha, no? This is our alpha. And 2 here is our beta, no? So substituting, meron tayong y equals c sub 1 cosine, what's our beta? That's 2 x plus c sub 2. Then we have sine beta, but our beta is 2. Oops, sorry. Our beta is 2 x, and then e raised to what's our alpha? That's -3. So -3 and then x. Ayan. So now we have our general solution, which is this one. And so since we were given an initial value problem with conditions y of 0 equals 3 and y prime of 0 equals 7, then solving this equation, no, and applying the solution, applying the condition at y of 0 equals 3, we're going to get, copying yung ating general solution here, y, we have y equals c1 cosine 2x plus c2 sine 2x, this quantity multiplied by e raised to alpha x, which is -3x. Okay? And so, evaluating, no? We're gonna have, we know that this is our y, right? And this is our x. And so substituting, meron tayong 3 equals c sub 1 cosine 2. We know our x to be 0 plus c sub 2 sine 2 and then multiplied again by 0. Quantity, that quantity is multiplied by e raised to 3, then again multiplied by 0. Okay? Simplifying, we know that e raised to 0 is 1. We know that sine 0 is also 0. And then 0 multiplied to anything is equivalent to 0. So this whole factor or term, excuse me, this whole term here becomes 0. Whereas cosine 0 here becomes 1. Alright? So further simplifying, kakaroon tayo ng 3 equals c sub 1 plus 0. So that's already c sub 1. Okay? C sub 1 equals 0. Okay. Now, applying our second condition at y prime of 0 equals 7. At y prime of 0 equals 7, let's take the first derivative of y for us to be able to apply the condition. So, derivative ng cosine 2x, that's actually negative 2. Negative 2 c sub 1 sine 2x. It's the derivative plus derivative ng c2 sine 2x. Yes. 2c2 cosine 2x. And then this function here is multiplied by e raised to negative 3x. So again, meron tayo ditong two factors, no? Itong factor na ito, this could be u, this could be v. So by product rule, maalala pa natin, product rule, which is u prime v plus uv prime. Yan. Kung ito yung ating unang finactor na term, edi copy natin si e raised to negative 3x. And next, by product rule, plus, copy natin si first term and then differentiate natin si second term. C sub 1 cosine 2x plus c sub 2 sine 2x. Then, derivative ni negative e raised to negative 3x, that's, yes, negative 3 e raised to negative 3x. Yan. So, evaluating our DE, substituting the value for 7 and 0, meron tayong 7 equals negative 2c1 sine, then 2, then multiplied by, again, 0, plus 2c2, then cosine 2, again multiplied by 0. This whole factor here is multiplied by the exponential negative 3 and again multiplied by 0. Yan. Okay? Then plus, kabila naman, we have c1 cosine 2 and then multiplied by 0 plus c2 sine, again 2 multiplied by 0. This factor here again is multiplied by negative 3 e raised to negative 3, again multiplied by 0. Yan. And so evaluating, medyo mahaba, no? Evaluating, we know that e raised to 0 again is 1. We know that sine 0 is 0, so this whole term here becomes 0. Cosine 0, as we know it, is 1. Again, e raised to 0 is 1. Cosine 0 is 1, but sine 0 is 0. So that whole term cancels out. So simplifying, we'll get 7 equals 2 c2 and then plus, ayun, we have c1 multiplied by negative 3. Ayun, okay? But we know already c1, no? Ano yung c1 natin? Ito yun, 3 equals c1. So substituting yung value natin for this c, no? Magkakaroon tayo ng ganitong expression. 7 equals 2 c2 plus, ayun, 3 multiplied by negative 3. Okay? Yan. Negative 3 times negative, 3 times negative 3 is negative 9. If we transpose this here, this becomes 9 plus 7, which is 16. Divided by 2, C2 therefore will be equal to, yes, 8. You got it. Yan. So, meron na tayo ng C1 and C2 natin. Thus, no? Yung ating general solution of y equals c sub 1 cosine beta x, which is 2x, plus c sub 2 cosine 2x, this quantity multiplied by e raised to negative 3x, has a particular solution. A solution to the initial value problem. We have y equals 3 and 8, right? 3 and 8. So therefore, c sub 1 is 3 cosine 2x plus 8 cosine 2x. That quantity multiplied by e raised to negative 3x. All right. 3 cosine 2x plus 8 cosine, sine. This should be sine. Yan. It should be sine. Yan. Okay. That's it. This is our solution, particular solution for the initial value problem. Okay? So far, nakita natin in action, case 1, case 2, and case 3. Okay? Oops. So, moving on. Now, for higher order differential equations with constant coefficients, we actually employ a similar manner of finding the general solution. So, consider the equation as shown, an nth order dE being a sub n, y raised to n plus a sub n minus 1 multiplied by y raised to n minus 1 plus until a sub 1 y prime plus a naught y equals 0, where the coefficients a sub I and I equals 0, 1 until n are constants. Now, considering that equation given to us, we will get the same possible roots. Again, assuming na constant yung coefficients natin. This is applicable to constant coefficients pa lang. We will get possible, various possible cases, depending on the nature of the roots ng ating equation. Now, the principle of superposition is evident in this case. And the number of the arbitrary constants c sub n in the solution y sub n will depend on the order of the dE. And that is for k sub 1, real and distinct roots. If the real and distinct roots of the characteristic equations are m sub 1, m sub 2, until m sub n minus 1 and m sub n, then the general solution is, from the principle of superposition, alam pa natin to, the form is y equals c sub 1, y sub 1 plus c sub 2, y sub 2, until c sub n, y sub n. Right? Depending kung ano yung n. N would be equal to the order of the dE. So, in other words, kung third order yan, edi hanggang c3, y3. Kung hanggang fourth order yan, edi c4, y4. Magi-increase siya na magi-increase. The number of, the order, the number of roots will be dependent on the order of the dE. So, makatuwid, we have y equals c sub 1 e raised to m sub 1. Again, if we are seeking a solution that has the form y equals e raised to mx, we are seeking a solution that has a form of e raised to mx, then the general solution for higher order dEs, with real and distinct roots will be y equals y equals c sub 1 e raised to m sub 1x plus c sub 2 e raised to m sub 2x until C sub n e raised to m sub n x, where n is the order of the differential equation. Okay? Next. We have, of course, paano kung naulit-uli yung roots just like before? We have case 2, real and repeated roots. If the characteristic equation has repeated and equal m sub 1, m sub 2 until m sub n minus 1 until m sub n, then the general solution is given to us by y equals c sub 1 plus c sub 2x plus c sub 3x squared until c sub n x raised to n minus 1. Papansin natin kung ano yung nth order ng ating DE. Let's say, for example, third order DE. Pag third order siya, edi hanggang c sub 1, c sub 2, hanggang c sub 3, x squared. Pag fourth order yung DE, edi hanggang c sub 4, x raised to 4 minus 1, which is 3. Yan. So, mapapansin nyo, no? Yun yung purpose actually kaya ko siya nilagay yung x sa C2 instead of C1. Para makita natin yung pattern that C1 plus C2x plus C3x squared plus C sub n x raised to n minus 1 ay may pattern, ano? It is expanding. The same method kasi of the Allenbert applies here. And so for repeated roots, we will notice that the power of x, this case, this x here, which is raised to n, depends on actually the nth order. And the time n times the root is multiplied. In other words, when n minus 1. So kung ang order mo is 4, edi asahan mo na yung highest order or highest exponent mo will be x raised to n minus 1. Kung 4, edi cube. Okay? So nagigets natin, as long as habang lumalawak or tumataas yung order ng DE natin, dumadami yung constants natin, and yung x or yung power ng x succeeding. So yung unang constant lang yung walang x. Yung succeeding constants ay meron ng x's, no? That will distinguish it from the original root. Alright? So yun yung mapapansin natin sa kanya. Meron siyang expansion or pattern. Thirdly, of course, is kapag ka, again, imaginary complex conjugate yung roots. If that is the case, then c sub 1 cosine beta x plus c sub 2 sine beta x multiplied by e raised to alpha x would be our general solution again. So alam na natin yan from second order. Pero kasi in some cases, merong mixture sometimes ng complex and then real. For example, merong roots na ganito. M equals 1 and then 2 plus or minus 3i. So, actually, 3 roots to, no? 1 and then ito kasi 2 roots to eh, no? So, pwedeng ganyan yung maging case. And if that is the case, anong pwede natin expect sa ating general solution? E di, since ito ay real, no? Sure na to na C1 e raised to mx lang yan or e raised to x. Plus, edi ito naman, ano? Yung general solution is this one, C1 cosine beta x plus C2 sine beta x. Edi add lang natin C1 cosine beta x plus C2, C3 na pala. C2 and then C3 kasi continuous yan. Para distinguish natin yung constant coefficient. Sine beta x. No? And then, of course, this pair here is multiplied by e raised to alpha x. Ayun. So, ganun siya, no? Pwedeng mixture siya na yung roots ng real and complex. Now, of course, paano kung na-repeat naman, no? If the characteristic equation has complex or imaginary roots, say for example, m equals alpha plus or minus j beta, which is repeated n times. For example, yun nga, kung ang roots mo ay 2 plus or minus j3, no? And then naulit pa uli, 2 plus or minus j3. So, kung ito ay 2 roots at 2 roots, so alam natin na fourth order yan, no? Pag ganyan yung nangyari, ibig sabihin, twice siya na-repeat. At pag twice siya na-repeat, itong complex conjugate, edi hanggang c sub 2, no? Or hanggang c sub 4. Actually, c sub 3 at c sub 4 ito, no? Increasing. Nagbabago rin yung numbering dito to distinguish it from the number of constants. C sub 3, C sub 4. until c sub n x raised to n minus 1. No? So, makakaasa tayo na ang form ng general solution natin, if that is the case, would then be equal to c sub 1 plus c sub 2 x, no? Y equals, kunwari, for example, ito yung root, no? Or roots, or eigenvalues. C sub 1, C sub 2x, and then cosine beta x. What is our beta here? Our beta is 3, so cosine 3x. And then plus, no? Ganun uli dito, C1 plus C2x, or rather C3, C4. And then sine 3x, and then multiplied by this whole equation, no? E raised to alpha x, which is e raised to, what is our alpha? 2. Yan. Okay? So, C1, C2, C3, C4. So, ganyan yung mangyayari. So, depending on the number of times na nirepeat siya, kung ilang beses siya nirepeat, edi doon din yung dami, no, ng ating constants. Or kung ilang beses madadagdagan yung ating x. In this case, kung 2 siya, edi x raised to 2 minus 1. So, yes. One thing another we could notice is that in this case, the sine and cosine, no, the sine and cosine form remains, while only the constant coefficient are expanding. So, pag nare-repeat n times yung complex conjugate natin, ito lang yung lumalawak. And then, nare-retain yung cosine and then sine. Sine. Okay? So, yan. I hope you're getting some of this. Now, to summarize it all in a table, here, I have curated, no, yung general solutions, the case and their respective general solutions. Okay? All right. Now, sometimes it is convenient to express derivatives in terms of what we call D operators. Okay? Now, recall, nung ating prelim, we have discussed this on different kinds of notations, that y prime could also be expressed as dy over dx, which could also be expressed as d sub y, and simply d. Now, usually the independent variable in this notation, yung dy, no, is dropped so that dy could also be expressed as d. Now, the exponent of d denotes the number of times that the function will be differentiated. Okay? Now, like as a polynomial, the order of the DE is expressed in terms of an exponent of the D operator. So, the D operator, or the linear operator, is an algebraic polynomial in which the differential operator D plays an important role, or a role of a variable. So, for example, we have y triple prime plus 2y double prime minus 5y prime minus 6y equals to 0. No? And if you're asked to convert this into its equivalent D operator form, we can expect that this would be equivalent to yan, d cubed plus 2d squared minus 5d minus 6. No? So, mapapansin nyo, by inspection lang talaga kung ano yung number of times na i-differentiate yung ating differential equation. In this case, y cubed. Ang equivalent niya to its d operator is d cubed. So, yung order ng dE is equivalent dun sa exponent ng d. Yan. So, papasin niya rin dun sa 6y na wala na yung y because d is already considered as d sub y, or that y is the dependent variable. Okay? So, D operator, or the Euler operator notation, allows us to obtain a compact expression of equations for a quicker solution. So, this is evident actually not only in higher order differential equations, but also in electromagnetics or vector analysis, where we see the del or nabla differential operator in action. We also see the gradient, no, divergence, and curl of V in this case. The introduction of differential operators allows us to investigate differential equations in terms of operator theory and functional analysis. This generalized approach turns out to be powerful and effective. In particular, considering applications to higher order differential equations, we obtain a compact way of writing equations and in some cases, the possibility of a quick solution. So let's take a look at some sample problems and see the concepts we have learned as well as the D operator in action. So example number 4. Okay, so we're given a differential equation of an equation expressed as d cubed minus d squared minus 4d plus 4. From our earlier discussion about the linear operator, the differential operator, the D operator, it can already be seen by inspection that the D operator has already a similar semblance from the characteristic equation. That is why if we're going to proceed with our strategy in solving this, getting our characteristic expression, or rather characteristic equation, this could simply be expressed as, yes, m cubed minus m squared minus 4m plus 4 equals 0. Diba mas madali kapag naka-D operator na siya to translate into the characteristic equation. What's next after this? We actually need to figure out what the eigenvalues or the roots are. At yung roots na yun are m. So what are the roots? Actually, this is algebraically we can manipulate the equation and see to it that we can factor out d minus 1 here from our equation. So let's first copy this one. M cubed minus m squared minus 4m plus 4 equals 0. We can factor out m minus 1 from here. So magkakaroon tayo ng m squared, m minus 1. If I factor out m squared here, and then minus 4, and then m minus 1 equals 0. So we're left with the factor m minus 1. We can factor out m minus 1 totally and arrive with m minus 1 and then m squared minus 4. Yan, equals 0. Okay, so by inspection, we can already see that the roots are m equals 1, 2, and negative 2. Paano natin nasabing 2 and negative 2? Well, the square root of 4 is 2 and negative 2. Yon. Kaya 1, 2, and 2. The easiest way to do this, or if you want to verify actually, is of course to use our calculator. So please go to mode 5 and then 3. I'm sorry, mode 5 and then 4 because that's the cubic. That's the cubic equation here. So 4, choose 4. And then plug in yung ating mga coefficients. We have 1, negative 1, negative 4, and then 4. Equals, and then we'll have negative 2, 2, then 1. Right? So verified, 1, 2, and negative 2. Kahit ano naman yung arrangement niyan, by a principle of linear combination, they would just be the same solution. That is why, if that is our roots, 1, 2, and negative 2, they are all real and distinct, that this falls under case 1, right? So this one is case 1, which is real and distinct. And so we know that the general solution is y equals c sub 1 e raised to m sub 1 x plus c sub 2 e raised to m sub 2 x plus c sub 3 e raised to m sub 3 x. Thus, no, our general solution, y, would then be equal to c sub 1 e raised to, yes, x. Simply because yung coefficient natin is 1. Right? And then plus c sub 2 e raised to 2x. 2x. And then c sub 3, of course, e raised to negative 2. Yan, x. All right. And here we have it, ladies and gentlemen, our solution. Since wala naman tayong condition na given, hindi particular solution yung hinahanap, hindi siya initial value problem. That is why, yeah, we end up with this kagad as our solution. That's the general solution. Okay? Easy, right? Okay. Let's try another example. How about this kind of equation here? So, same, no? Just like the previous example, it is expressed in its d operator. So, by inspection, could already be identified that the characteristic equation here can be expressed as m to the fourth, or 4m to the fourth, minus 4m cubed minus 23 m squared, 23m squared plus 12 m, and then plus 36 equals 0. Okay? Now, sa ganitong case, finding the eigenvalues, which is m, would be kind of difficult, most especially to those na mayroong calculator na hanggang cubic lang. Most especially, if I'm not mistaken, dun sa mga calculators na board exam allowed. Kasi, if I'm not mistaken, yung math whiz na calculator na kaya up to 4th, well, kung meron ka nun, kaya nyan i-solve yun nun. Pero those na hindi allowed for the board exam, if I'm not mistaken, ang most of the calculators na recommended or are required or allowed by PRC are those na up to cubic lang, if I'm not mistaken. That is why my recommendation to you is that if you are an engineering student with a board exam, I would recommend that you choose a calculator na allowed by the PRC para doon kayo masanay and that you would be able to master every feature na meron doon sa calculator na yun. So, for those na ang calculators ay, for example, Casio 991ES or 570, well, we know na hanggang cubic lang ang kaya niya. And this kind of equation, hindi na siya kaya. So, what do we do now? So, in these cases na mataas na yung degree ng ating polynomial, we will employ a technique. And this technique, natutunan nyo na ito sa inyong algebra. And this is what we call synthetic division. Synthetic division. Synthetic division. And paano yung synthetic division? Well, basically, kung meron kang equation, you will just have to take the coefficients of the equation. So, for example, kung ang ating equation is 4m squared or 4m to the fourth, 4m cubed, 23m squared plus 12m plus 36, we have to get the coefficients So, kopyahin natin sila lahat. For example, kung meron tayong 4, then negative 4, then negative 23, and then 12, and then 36. No? We have to be cautious, no? Kasi we have to take yung coefficients nung lahat ng ating representative ng equation. So, kung meron kang fourth order dito, tapos sa equation mo walang third order, hindi dapat ilalagay mo dun 0. No? So, magmamatter din yung position niya. So, after taking yung mga coefficients natin, no, we will be dividing this to a root. So, ano yung root na yun? No? That's the question. What is that root? At dyan papasok yung ating calculator kasi we can use or utilize our calculator to guess for a root. Yes, so mga hula tayo, no? Pwede natin kapain kung yung isang root, kung yung isang value ay belong dun sa root ng ating equation. Again, fourth order yan or fourth degree yung polynomial natin. So makakaasa tayo na apat dapat yung magiging degree niya. Or sorry, apat dapat yung magiging roots niya. So, what we must do is to simplify yung equation natin by finding a root and then pag na-divide mo na kasi yan, mababawasan siya ng 1 degree. Yung magiging sagot niya, magiging cubic na, no? At pagka cubic na siya, yun, pwede na natin ulit gamitin yung calculator natin to find the roots. Okay? So, let's go ahead and do that. So, ano yung root na pwedeng i-divide dun sa ating equation? Yun yung ating hahanapin. And let's use our calculator, no, to do that. Una, input natin yung ating equation, 4, and then let's represent m as x. 4x to the 4th minus 4x cubed, and then minus 23x squared, and then plus 36 plus 12 plus 12x, and then plus 36. Yan. Double check. 4m to the 4th minus 4x x cubed minus 23x squared plus 12m plus 36 equals 0. So, dapat, pag nahanap natin yung root, it should make the whole equation 0. Paano natin gagawin yun? Well, gagamitin natin yung calc. Let's press calc, and then magtatanong siya, what would be the value of x that you want to substitute dun sa given equation natin kanina so that we'll be able to get a number? Again, ang goal natin, dapat maging equal to 0 siya para malaman natin na root. Right? So, start tayo sa 1. Let's choose 1. So, 1. Ang sagot niya 25. So, definitely, hindi siya root. 1 is not a root. Let's try another one. When x is equal to 2, the answer is nag-0. So, ibig sabihin, a possible root, or sure na root yun, no, is 2. Doon sa apat na roots na aasahan natin, may isang sure na tayo, which is 2. So, doon natin i-divide yung ating equation sa 2. Okay? So, naalala pa ba pag synthetic division? Pag synthetic division, una, ang kailangan ay ibaba yung first coefficient. So, bring down 1, no? Yan. So, si 4. So, si 4, multiply natin kay 2. So, magiging 8 siya. And that 8, the product of 4 and 2, will be placed here. So, 8. Yan. And then, we add them, we add these values, 8 and negative 4. So, this will be obviously equal to 4, right? And then, 4 times 2, again, is 8. Yan. And then, 8 minus 23. So, pag nalilito, pwedeng gamitin yung calculator, 8 minus 23, for even the mundane tasks of arithmetic basic. So, negative 15, right? Then negative 15 times 2 is negative 30. And negative 30 plus 12 would be negative 18. And negative 18 times 2 is negative 36. 18 plus 18, 36. And of course, 36 minus 36 would be 0. Yan. So, kung ito kanina is 4m to the fourth, negative 4m cubed, negative 23m squared, and 12m, and then 36, this new coefficient here brought about by the division will now be equivalent to an equation of, magiging ganito siya, 4, and then m cubed, mababawasan ng isa, and then plus 4m squared minus 15m minus 18 equals 0. Ayan. So, meron na tayong cubic equation wherein we can now use our calculator to solve for the roots of a cubic equation. So, let's go ahead and do that. Let's go to mode 3. Mode 5. Mode 5 and then 4. Yan. And then let's put in our coefficients. We have 4, negative 15, and negative 18. Let's check, no? Meron tayong, so including this 2, no? So when m is equal to 2, so ang roots natin by calcu, mode 5, 4. Yan. By mode 5, 4, meron na tayong, if this is, let's call this m sub 1, no? Meron na tayong m sub 2 of 2 uli, no? And then again sa calcu, you have negative 3, negative 1.5, okay lang ba? Negative 3 over 2. And then, ano pa? So, mula dun sa calcu natin, may lumabas na 2 at saka negative 1.5. Supposed to be pa cubic yan, makakaasa tayo ng tatlong roots, tama? So, since dalawa lang yung nilabas ng calcu natin, ibig sabihin may isa dyan na nag-repeat. May isa dyan na nag-repeat. The question is it 2 or is it 1.5 na nag-repeat sa kanya? Ayun. No? So, ibig sabihin, we cannot conclude pa kasi, again, we're looking for 4 roots. And what should we do when we encounter such roots na nag-repeat na we can't identify? What we're going to do is to use synthetic division again. Okay? So, in this case, no, pwede naman tayo mag-choose ng kahit ano, pwedeng 2 or negative 1.5 kasi if we divide the root 2 or 1.5, magkakaroon uli siya ng another equation. And that time, quadratic equation na siya. And then from there, yon, we can use again our calculator and figure out kung ano yung nagre-repeat. Okay? Yon. So, let's try, no? Try again. When m is equal to 2, by synthetic division, okay lang, let's call it SD. By SD, when m is equal to 2, when m is equal to 2, so yung root natin will be 2. Again, no? And then this one is divided or dividing our expression for this equation here, no? Kunin natin yan. Kunin natin yung 4. Kunin natin yung 4. kunin natin yung negative 15, and then kunin natin yung negative 18. Okay? Okay. And then, yan. Let's divide it to 2. First step, bring down muna natin yung leading entry, which is 4. So this will be 4. 4 times 2 is, again, 8. 8 plus 4 is 12. 12 times 2 is 24. And then 24 minus 15 is 9. Pag nalilito, mag-calculate ulit. Okay? Kahit yung napaka-basic na 24 minus 15 is 9. Yan. Nagda-doubt pa ako, no? Tama naman pala ako. 9. Okay. Oops. So, 9. Oops. And of course, 9 times 2 is 18. Yon. And then 18 minus 18, of course, is 0. All right. So from here, no, we can now generate, no, a quadratic equation which has an expression of 4m squared plus 12m plus 9 equals 0. Ayan. So in this case, no, let's again use our calculator. Let's bring out our calculator. And then solve the quadratic equation, mode 5 and then 3. Input yung ating coefficients. We have 4, 12, 9. And see na, si negative 3 over 1/2 yung nagre-repeat. So, yung roots niya is negative 3 over 2 and negative 3 over 2. No? So, in other words, the missing m sub 4. So, ayun. Oops. So, the missing 4, the missing m rather, the missing root. So, again, by calcu, mode 5, 3, mode 5, 3, we get the roots negative 1.5 and negative 1.5. Okay? So, thus, the roots are m sub 1 equals, itong nakuha natin kanina, itong guess natin kanina, 2. M sub 1 is 2. And then m sub 2 is 2 again. And then m sub 3 is negative 1.5. Then m sub 4 is again negative 1.5. Yun. So from here, therefore, yung ating general equation, since this is case 2 and case 1, kasi real and distinct and real and repeated, real and distinct in the sense na 2 and negative 1.5 siya, real and repeated in the sense na 2 and 2 and then 1.5 and then 1.5 siya. Therefore, yung general solution natin would be a mixture of both cases, case 1 and case 2. And this will be c sub 1 plus c sub 2 x, okay? And then multiplied by e raised to, unahin ko muna yung 2x, kasi repeated sila, and then plus, yun, c sub 3 plus c sub 4 x, then e raised to negative 1.5 x. Ayun. And that, ladies and gentlemen, is our general solution for this problem. Okay? Nakuha, guys? So, since fourth order yung D natin, makakaasa tayo na dapat 4 distinct arbitrary constants yung meron. Hindi siya C1 plus C2x, no? Kasi nga, 4 dapat na distinct. So, C1, C2, and then C3, C4. Okay? Yan. Interchangeable naman sila. Pwedeng ito yung mauna, maging C1 plus C2x e raised to negative 1.5x, and then C3 plus C4x e raised to 2x. By principle of superposition, parehas lang din sila ng makukuha. Okay? So, yan. Let's take another example, no? Example number 6. Yan. So, same expression, naka-D operator, and from here, we can already, by inspection, see na the characteristic equation is m raised to 5 minus m raised to 4 minus m plus 1 equals 0. Okay? So for this one, again, pwede natin to i-manipulate, no? And or pwede rin tayong mag-synthetic division. So, whichever technique, okay lang. So, B, hanapin natin yung eigenvalues. Yung roots niya, M, no? And how are we going to do that? Well, again, we can do synthetic division. So, by SD, no? Input lang natin yung ating coefficients. So, may 5, 4, pero wala tayong cubic at wala tayong quadratic. Meron lang tayo yung m raised to 1 niya. So, paano natin to i-represent sa ating synthetic division? E di magkakaroon tayo ng 1 for m to the 5th, and then 1 for negative 1 for m to the 4th, and then 0 for m cubed, na kanyang coefficient for yung counterpart na x cubed. Sa x squared, 0 din dahil wala naman siyang representation. And then negative 1 for x, and then 1 for the constant. Okay? Again, ito yung m to the 5th, m to the 4th, m cubed, m squared, m, and then yung constant mo. Okay? And then, ano uli yung gagawin natin dito? We will be looking for or guessing, quote-unquote, what would be a possible root. Okay? Yan. Let's call it m sub 1. So, let's use our calculator, no? Punta tayo ng mode 1. Punta tayo ng mode 1. So, sa calculators natin. Yan. And then, input natin yung equation. Let's represent m as x. Although, may m din naman dito. Whichever. Sige, gamitin lang natin yung m for the sake of variety. Minus m to the 4th minus m. And then plus 1. Yan. M to the fifth, M to the fourth, minus M, and then plus 1. And then, you know what to do? Calc. Calc natin siya, and then it will ask for M. I usually start by guessing 1, and then onwards, and then afterward, try negative values, ganyan. So, it could be anything, from negative infinity to positive infinity. Actually, meron pang another mode for that, no? We can, naalala ko lang ngayon, no? We can also use yung table, no? Mode 7. Yan. So, magtatanong siya dito ng value for f of x. And then, it will give you a value of x and y na table, no? Pero hindi ko na siya i-explain. Papakita next time na lang due to time. So, going back, napurot tuloy, sorry. So, input ulit natin, m raised to 5 minus m raised to 4 minus m plus 1. Yan. Daming features ng calculator natin. So, be sure to be able to familiarize yourself. Kasi magagamit nyo yan, may utilize nyo yan in your advantage. No? To your advantage. So, m raised to 5 minus m raised to 4 minus m plus 1. And then calc. Then, I usually start with 1. So, 1 equals... nag-zero ka agad. No? So, ibig sabihin, 1 is a root. So, let m be equal to 1. Let m be equal to 1. Yan. So, let m sub 1 be equal to 1. So, alam na natin ang gagawin. We divide this. And then, bring down yung leading entry. So, this is 1. No? 1. And then, 1 times 1 is 1, of course. And then 1 minus 1, obviously, is 0. 0 times 1 is 0. This will be 0. 0 times 1 is 0. Bring down 0. And then 0 times 1 is 0. And then negative 1 plus 0 is negative 1. Negative 1 times 1 is negative 1. And so negative 1 plus 1 is 0. Ayan. And this equation here, is equivalent to m raised to 4. Again, marireduce siya ng 1 kasi nag-divide ka ng isang root or ng isang factor. So, m raised to 4. And then, since wala na tayong m raised to 3, because 0 na siya, m raised to 2, wala na rin. M raised to 1, wala na rin. Meron na lang tayong k, which is minus 1. Actually, ilagay ko na rin, para hindi nakakalito. Plus 0m cubed plus 0m squared plus 0m minus 1 equals 0. In other words, this will be m raised to 4 minus 1 equals 0. Okay? From the looks of it, ano kaya klaseng equation ito? M raised to 4 minus 1. Kung medyo hindi ka pa rin confident, pwede ka uling mag-synthetic division, Synthetic division. So, by SD, kung gusto mo uling mag-synthetic division, pwede ka uling mag-calc ng value na maaaring maging factor, nung ating equation. So, for example, m raised to 4, yung natitira sa atin. So, kung kunin ko yung coefficient niya, magkakaroon ako ng 1. Then, magkakaroon ako ng 0. 1. Magkakaroon ako ng 0. So, m raised to 4, m raised to 3, m raised to 2, m raised to 1, and then negative 1. Okay? Yes. And then I will divide this by m sub 2. What could be a possible solution for that? Again, di pa natin magagamit yung calculate natin yung equation 5, 4 dahil cubic yun. No? Eh, since galing tayo sa 5th and then naging 4th, ito ngayon ay nasa 4th pa. So, hindi pa tayo pwedeng gumamit sa calcu nung equation mode. But, pwede naman natin gamitin yung ating calc. Pwede tayong manghula uli, no? Ng isang value. Calc. What could be another possible value? Let's try 1 uli, no? 0 uli, no? Actually, pag nag-try ka ng 2 dyan, mali, 15, no? So, what could be a possible answer for that? Medyo obvious din, no? Kasi if it is asking for a value that would be equal to 0, I think 1 lang talaga ang pwede dyan maging sagot. And so, if the root is 1, no? Yan. So, dalawa ng 1. So, same, no? Dividing the equation by 1, bring down yung leading entry, yung 1. So, 1. And then 1 times 1 is 1, right? 1 plus 0 is 1. And 1 times 1 is 1. 1, 1, 1. And then 1 times 1 is 1. This becomes 0. Okay. So, in other words, meron ka palang equation na magkakaroon ka ng equivalent expression of m na m cubed plus m squared plus m plus 1 equals 0. Okay, baba ko lang ha. Hindi nakakalito. M squared, tama? Or m cubed rather. M cubed plus m squared plus m plus 1 equals 0. Ayan. Okay? And, sorry. And from here, it can already be, we can already utilize yung ating calculator, ano? To solve yung ating cubic equation. So, let's go ahead and do that. Let's go to mode, and then 5, and then 4. And then input natin yung values 1, 1, 1, 1. And then equals. So, meron tayong negative 1, I, negative I. Okay. So, meron tayong nakuhang values na root by calcu, which is mode 5, 4. Yan. By calcu, mode 5, 4. May nakuha tayong roots. Let's call it m sub 3 kasi m sub 1, m sub 2 na. So, labas ulit natin si calcu. Ano ulit yung roots? Nakuha natin kanina. Negative 1. What else? M sub 3. M sub 4. Oops. M sub 4 is I, or let's call it J. Okay lang. And then M sub 5 is yun, negative J. Okay. All right. So, in other words, no? Mas ko lang yung calcu. Lagay ko lang dito. So, thus, yung ating roots to summarize, no? Ay merong 1, 1, negative 1, positive negative J. Okay? So, 1, 1, negative 1, and then positive, negative j. Yan. And so, therefore, our general solution, y, is, meron tayo ditong repeating, dalawa, in yung 1, 1. And then, meron tayo ditong isang negative 1. So, ito real and repeated. Ito real and distinct. And then, ito naman, complex. Case 1, case 2, and case 3. All present at the same problem. So, paano mangyayari pagka ganito? Well, kunin natin muna itong 1, 1. Meron tayong C1 plus C2x. And then, e raised to, since 1 lang yung x, edi x lang. Okay? Lagay ko na rin yung 1. Yan, okay? 1 lang yan, ah. And then, of course, plus, by principle of superposition, we have, this is a real and distinct, so medyo easy lang to, e raised to negative 1. Negative 1. Then x. Okay? And then plus, ayan, since this is a complex value, no, we know that the solution for case 3 is c sub 1. Or wala pala yung constant dito. Dapat may constant to. C sub 3 to. Sorry. So, C sub 3. Plus, so, alam natin na yung complex exponential ay mayroong form na C sub 1 cosine beta x plus C sub 2 sine beta x, and then that quantity is multiplied by e raised to alpha x. So, dito, magiging continuous lang kung ito ay C1, C2, ito ay C3. Okay? And then plus C4. C4. And then cosine. What is our beta? That's 1. So cosine x lang. Right? And then plus sine or C5 sine x. Okay? And then e raised to alpha x. E raised to alpha x. But alpha is, ano yung alpha natin here? Alpha is actually equivalent to 0. Wala siyang real part, no? So in other words, e raised to 0x. And we know that e raised to 0x is 1. Yan. Kaya naman, yung ating magiging solution ay simply y equals c sub 1 plus c sub 2x e raised to x plus c3 e raised to negative x. And then plus C4 cosine x plus C5 sine then x. Yan. So, kung mapapansin nyo, no? Ito yung case 3 na equivalent nito. Ito yung case 1 na equivalent nitong negative 1. At ito yung case 2 na real and repeated. And with that, ladies and gentlemen, is our, of course, final solution. Yan. Okay? So, yan. Okay, how about another problem? So we have here d squared plus 36 squared plus y. Okay? Now in this case, yung ating characteristic equation, madali lang uling makapansin at makita sapagkat by inspection, the characteristic equation can already be seen as m or expressed as m squared plus 36 then squared equals 0. Now, since alam natin this one is raised to 2, so we can be confident in knowing na this is m plus 36, m squared plus 36, as well as m squared plus 36, right? And simply by inspection, this will simply become m equals negative 36, m squared that is pala. And we know but by taking the square root of both sides, no, magkakaroon tayo ng m equals negative 36, that would be positive negative j6. Ayun, positive negative j6. But since dalawa siya, no, so ibig sabihin, yung m natin, sinolve ko na, no, yung roots, yung m natin would be equal to dalawa. Positive negative j6 and then positive negative j6. Okay? Sige. Range ko lang ito. So, dito ko siya ilalagay sa part ng eigenvalues. Okay? Yan. So, m equals dalawang positive negative 36. No? And here, we can already know that this is case 3 and case 2. No? Since repeating siya, actually case 4 pala. No? This is case 4. Sorry. So, in case 4, as we know it as a general solution of c sub 1 plus c sub 2 x, no, cosine beta x plus c3 plus c4 x and then sine beta x, and then of course this 2 here, or the whole equation rather, is, I'm sorry, this quantity only is multiplied by another quantity, alpha x. Ayan. Okay? So from here, can already be substituted, no, directly, that this will become c1 plus c2 x, and then cosine, since yung roots natin ay j6, again wala siyang alpha, no, na component. Ang meron lang siya ay yung imaginary component, which is 6. This is beta, right? So this will become cosine 6x. Okay? And then plus yung ating c3 plus c4 x, and then of course sine 6x. This is multiplied by e raised to 0 x, and we know that e raised to 0x is 1. So therefore, our final answer, y equals c sub 1 plus c sub 2x cosine 6x plus c sub 3 c sub 4 x yan, and then sine 6x. Yan, that's it. This is our general solution. Yon. Okay? So, medyo madali lang, no? Medyo tricky. Dahil, parang hindi naman fourth order ata to. Dahil d squared plus 36. Pero raised to 2 kasi siya, no? So, d raised to 4 yan pagka in-expand. So, makakaasa ka na, since fourth order DE, 4 din dapat yung arbitrary constants. Okay? Yon. So, let's move on. And I think this is our final example. So, paano naman pagka ganito ang ating problem na may encounter? Okay? We have d squared plus 4d plus 20 squared y equals 0. So, same, no? Identify first the characteristic equation. And since naka-d operator na siya, again, madali siyang ma-identify kaagad. So, m squared, or rather, ma-compose agad. M squared plus 4m plus 20. In this case, this is again raised to 2 equals 0. Next is we find the eigenvalues or the characteristic roots m. And from the looks of it, this is a quadratic equation that is raised to 2. So, fourth order uli ito. Luckily, pwede na natin gamitin yung calculator natin, no, to solve for that. So, again, mode 5, and then 3. Then, input natin yung values natin, 1, 4, and 20. The answer is negative 2 by calcu again, which is mode 5, 3. By calcu, mode 5, 3, m sub 1 gives negative 2 plus j4. And then what else? Then m sub 2 equals negative 2 minus j4. Okay? So, in that case, ganun ulit, no? Since raised to siya, makakaasa tayo na yung m sub 3 niya at m sub 4 ay parehas lang, no? Parehas lang. So, negative 2 plus j4 at negative 2 minus j4. Sa makatuwid, no? Sa makatuwid, this m here would be expressed as negative 2 plus or minus j4 complex conjugate na pairs, no? Then negative 2 plus or minus j4. Ayan. So, medyo mas maliwanag na, no, na complex and repeated. Same lang din ng ating previous problem. So, in this case, no, C, this is again case 4. And the general solution for that is y equals c sub 1 plus c sub 2x cosine beta x plus c sub 3 plus c sub 4x. Yan. And then, of course, multiplied by sine beta x. This whole quantity is multiplied by e raised to alpha x. So, we can already identify from this equation that this is our alpha, no? Ito yung alpha natin. At ito yung beta natin. Yan. So, from this equation, negative 2 and 4 can already be composed. The general solution can be expressed as like this. So C1 plus C2x, okay? And then cosine, what's our beta? 4. Cosine 4x for 420. Yes, cosine 4x for being our angle beta. Yeah, for being our angle beta. So lagay ko na lang dyan. Plus C3 plus C4x multiplied by sine 4x. And then this whole quantity here is multiplied by e raised to negative 2. And then, of course, x. Yeah, and that, ladies and gentlemen, is our final solution. Okay? Ayun. That's it. All right. So here's our problem set 16. No, we have two problems lang for here. And that ends my presentation for lesson 16. Thank you very much for listening. And as Lasalians, may we respond in prayer and say, I will continue, O my God, to do all my actions for the love of Thee. Saint John Baptist de La Salle, pray for us. Leave Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Thank you guys for listening, and see you again to the next lesson. Bye-bye.